Hello, my name is Clara Boanova and I am Sales Manager at M&O Partners. I hope that you and your family are safe and healthy. Welcome to our Technical Thursday. Every Thursday, 10 a.m. local time, we receive a different partner to present their solution for maritime and oil and gas industries. Today, we have Farsounder with Safely Navigating the Unknown. This webinar is a partnership with UBM. I would like to introduce you to our presenter. Cheryl Zimmerman is the President and Chief Executive Officer of Farsounder, a marine electronics company which develops and manufactures advanced 3D forward-looking sonar systems. Since 2002, she has led the team in commercializing this innovative technology to global commercial, recreational, defense, and homeland security markets. She's a successful entrepreneur with over 30 years of experience starting and growing several technical and commercial business. She has led the Farsounder team and received numerous honors over the years, including 2015 Tibet's Award for Innovative and Outstanding Contribution to the Small Business Innovation Research Program. Her expertise has led her to lend her knowledge to various organizations, including the Marine and Oceanographic Technology Network and the New England Innovation Alliance. And she is a founding member of the Northeastern Regional Association of Coastal Ocean Observing, where she was a director as well a member of the executive committee. After the presentation, we'll have some minutes for question and answers. I hope you all enjoy it. Thank you.
Good morning. My name is Cheryl Zimmerman. I've been in the marine industry for almost 20 years, and I'd like to thank Clara and also UBM and M&O for this opportunity to brief this audience, your clients and customers and other interested parties. Today, I will be talking about how to safely navigate the unknown. For this technical time, we will focus on a few topics, but I'm happy to expand and answer any questions afterwards and stay as long as you have questions. We will start with understanding the capabilities and markets and how Farsounder started. What do? We have developed and we manufacture and ship all over the world our 3D forward-looking sonar systems. When we started the company, we focused mainly on navigation. We were looking for a solution to protect the northern right whales, as well as avoid accidents such as the Exxon Valdez. That was the impetus to start. So now we have become a pioneer in the field of advanced 3D forward-looking sonars. With our 6 patents, we do our development in the US, but we always think globally, and our customer base and our products are found all over the world. And we have added an important new tool to the Navigator's toolbox. So our flagship products are our navigation, the Farsounder Argos navigation series of sonars. We have been deploying the Argos 500 and 1000 as well as their predecessor systems for since 2005. We have been shipping systems. Mainly those were focused on the larger vessels. And recently, we just came out with our Argos 350, which goes out to a 350-meter range, a little shorter than the others. However, it's compact and it is now available for small, even 18-meter or smaller vessels. And so we have a product line crossing all sorts of vessels. Our flagship navigation sonars are used for shallow water navigation and for looking at all different hazards. And This is what we really focus on. However, over the years, we have expanded into underwater threat detection. We do some work in fisheries, but we're going to focus on navigation today. Some of our main markets have been cruise ships, super yachts, and largely now we are doing survey, research vessels, work in the defense markets, and we also have offshore supply vessels that have our systems deployed. Okay. So the technology, for those who are not familiar with 3D sonar and just what are the differences between that and other sonars that you may be more familiar with, I'd like to just do a quick technical background. You know, just why do we have 3D sonar? As I said, we wanted to prevent accidents. We had a technology that looked ahead instead of down and wanted to protect lives and protect vessels, and also lower the impact of the vessels on the environment. So you are all are familiar with the downward-looking echo sounders. A forward-looking sounder could be as simple as taking a downward-looking echo sounder and facing it forward. And yes, that would be considered a forward-looking sonar. A fishing sonar that goes that will take a ping and go 360 degrees could also look forward. However, as you go around the 360 degrees, the vessel has already moved forward, so it's really not useful to see the marine environment in front of you. So you can see the depth sounder does not see that rock until you get to it, and a mechanically rotating, forward-looking pinger could also miss both those rocks and other obstacles within the water column. A 2D sonar can take a slice at a horizontal or a vertical, but again, it could miss something on your port side, it could miss something important. Now you can see the radar above the water, and yes, that does rotate and does a great job, but sonar underwater goes at a much slower, the speed of sound goes much slower than a radar. So just mechanically spinning and trying to build a picture is not adequate for solving the navigation issues. What you really want to do is send out a sound in all directions in front of the vessel in the whole volume and sonify all the water from the sea floor up to the sea surface in order to be able to get all that information. So on each ping of the sonar, we can see the whole volume, and our Argos 1000 will see the volume out to 1,000 meters in front of the vessel. So that's an important difference between a 3D forward-looking sonar and others that will only either be a small pinpoint or a narrow sector. What kind of things do we want to see? Besides mapping the bottom and seeing where there are shallows, other stationary obstacles you want to be able to see, whether you're traveling in a fjord and there's a pinnacle popping up, if you're going through a reefy shallow area with rocks and reefs and trying to get through safely, large buoys, all sorts of stationary obstacles. There's also moving obstacles. As we see obstacles in the water column, not just the bottoms, we can see these moving obstacles that no matter what best charts you have, they're never going to have any of these located on them. A shipping container just under the surface of the water is a very good target, yet a radar is not going to pick them up if they're just under the water. You know, icebergs, all these are other very appropriate obstacles for us to see. Now, our navigation sonars do not see people. We filter out all the small obstacles, as it's really focused on anything that is large enough to harm the vessel. So just to quickly show the difference between 2D and 3D processing. On the left, you see the traditional 2D processing, similar to a Navy sonar, where you can see the lighter spot on a diagonal in the center, but no matter how high the resolution is of this, you will not see where it is in the water column. Is it just a mark on a sandy bottom that's brighter and you can easily pass over it? Or is it something sticking up? On the right-hand side, you can see that we process not only in the XY, but also the depth. We see all 3 dimensions. So we can see where that bright spot is in the water column. But again, that's not useful if you're a navigator, you quickly want to know what's happening. So we process this even further. We extract this 3D information about both the bottoms as well as the in-water obstacles. So we can see, and we can put it on a grid and show just where it is, so that instantaneously you can comprehend, and as you're traveling at speed, you'll be able to see where things are and be able to know whether you should turn away from this. So our user interfaces, we have many different ones, very user-friendly, but different operators will focus on different ones. So I'll show you some of the main ones. What we see here is a shallow bottom and then the obstacle further out. And this is our cool looking 3D view. So you can look at it from any angle. The user can change the angle. The white bar that you see is a 2D slice. It's all processed in 3D, but you can look ahead on any bearing and show this at the bottom of the screen, which is more familiar, like a echo sounder with its history, but we are looking ahead and seeing what's ahead in front of us. The same information can be done over a chart, which this is the screen that I would normally use, because I feel it really helps with understanding the maritime awareness of what is in front of you. So you can see on the left, yes, now we know that it's following the shoreline of the chart, and you can see the piers ahead of you, in front of you. So within our sonar platform, we have S57, S63 chart capability. We have CMAP Professional. If you already are using that on board, you might want to use that. And we also can export this data into a third-party ECDIS, such as NACO's Platinum, and we can also export it into survey sonar, sonar displays, such as QBS's Kinsey. That's another one. So there's all different ways to use the data, whether in our platform or exported. So the full interface can bring in NMEA data, so you know where on the chart it should be. If you don't need this, you can hide any of these screens and just show the ones you want. The chart screen on the lower right-hand side can be moved to become the main chart instead of the 3D. And you can see the color scales on the side. The bottom one, color is mapped to depth. So deep is, the blue is deep and safe, and the bright yellow is the shallow. And it's all user definable, so you can change it according to the draft of your vessel and the safety room that you want. You can see at the top left, you can turn on alarms, and that is all user definable also. And the top scale on the right is the decibel, how loud it is, which is more like you see on the Navy sonars. You can change it all to that. Okay, and one last screen before I show you a short video. This is our local history mapping. We have been doing real-time forward-looking sonars in showing the data in real time. You can see the wide field of view right here, and we've been doing that for a long time, since we started selling the systems, and now we are also showing the option of having the history of it. You can see the tail behind it, this deep blue, and that is all the data from where you've been, and you may save that and then play it back. We have been doing that ourselves in the lab for years, so now for customers have been wanting it, we have added this to the package. And on the right-hand side, here's an example where you could go back and forth and make a 3D chart for a survey, a quick little real-time survey. Let's say you want to do an anchor survey, and you want to see where the best spot is for anchoring. That's one application, and there are quite a few others. I'd like to show you just the sonar in action. Oh, it says it can't be loaded. Whoops. Oh no. Okay. Okay, here I have another picture of it. So if you can let me know if this is showing on the display. Here's a simple video showing the sonar field of view, the wide field of view, looking ahead, and we're seeing the orange are the pilings of the bridge as you get closer to it. So this is an easy one for someone who has not used a sonar before, to see obstacles that are both below the water and above the water. And this darker green is the shallow area of the bottoms, and the pilings would be in water targets. So you can see it in the 3D on the side or not. Okay, oh no, it's not letting me back into my, I have to go back in, no. Okay, I just want to do it. Okay, sorry about this. Don't know why it popped it out. Okay, and present again. And so loading, I will go. Okay, we'll go past these displays, and hopefully you saw the video. So other ways, you don't need an ECDIS to have useful applications. You could also do autonomous. The same data that we export to someone's ECDIS could be exported to an autonomous or smart vessel. The data could go right into the navigation controller, so that you now have important underwater information in front of this autonomous vessel in order for accident avoidance. It's just one of many applications. Quickly look at a few of the installations. These are in large bulbs. They can also be in a smaller bulb. You can see the sonar is inset a little bit. That's to protect it against any anchor chains that might be coming. But a narrow stem, a raked hull is fine. Also could be done right on the stem or off to the side. All different applications and installation options. Here's a hoist for our Argos 1000. That also is, this is for a research vessel, the Sir David Attenborough, but we also even have our 350 is ready to be installed on hoists also. We are environmentally friendly, have We don't hurt the whales or any of the marine mammals. We have had environmental assessments by the U.S. Navy as well as the Department of Homeland Security. I'll quickly look at some use cases and then can get on to some questions. Many of you may have seen pictures of this over the years. The Explorer originally was the first cruise ship to ever go to the Antarctic, and in 2007 became the first one to sink there. And it hit some rocks that were embedded in some ice, they believe, and sunk. Luckily, there was another vessel that rescued all the passengers. This was a very costly loss of the vessel, and it could also have lost many lives. They were quite lucky. The USS Guardian was near a reef in the Philippines, and the reef was like off the chart. It was on the chart, but in the wrong place, completely wrong. If they had had a sonar, they would have seen it anyway, a forward-looking 3D sonar. So they lost the whole vessel. They had penalties, environment, and this was a large disaster that could have been averted. The Fennica is another one that the chart showed that it was at a depth that was fine, and they were even at a higher tide, but yet they hit it. So the chart was not correct either. In my last use case, here's a breakwater from right outside a shipyard in Europe, where there was a new build going out for engine tests, and what happened was it hit something that they've been there every day or every week and had never had anything. And they hadn't turned on the sonar that was on board, because obviously the engines were important for them to get commissioned first. So we went back with them after insurance company paid for another sonar that hadn't been used yet, and went out, and we could see that this breakwater it ended up, the breakwater was a newer one. They had deposited rocks on top of the old breakwater, so you can see that a lot of the rocks came closer in to what had been an open channel, and that's what they had hit. So you might think, even in your own home port, that you know what's going on, and it might be off. And to any fleet owners and operators in the audience, the risk management perspective is very important when you're evaluating what you're doing. You know, just losing your propellers on a crew boat going out to a platform, or any type of ship repair from accidents and groundings, the time out, injuries to passengers. We can certainly help with your, saving your ROI by helping prevent these disruptions in business. So forward-looking sonar is not yet required globally. It's not by the IMO or yet insurance companies or coast guards. Yet they're used in every ocean of the world, in rivers, and all over the world for all types of vessels. And I can go on other applications in questions. So thank you. Hello? Clara there?
Yes, I'm here. I'm here. Now it's the moment for question and answers. Please submit your question in the Q&A panel. We already have some. Cheryl, if you please go there.
Okay.
You'll see that we already have some questions there.
Yeah, I just opened it up. I will read them, because I don't know if people see them, do they? No. Can you share the data you are collecting from the local history mapping and share it with our fleet? Someone asked. And yeah, currently on our base package, we are saving the data, like about an hour's worth of data. But we do have a collection program that we are working with some of our customers globally, especially some expedition cruise ships, some private yachts, and people who are going to different places. So where they are returning the data to us, it's terabytes of data, and we are using that to build we have an infrastructure of a database up in the cloud where we've been collecting data for years, and now we have built the infrastructure to be able to put all this data together. And we are looking for small fleets to start working with them to be able to, for the fleets to share the data among their own fleet. And this is processed with the customer data collections program that we have going now. And we do hope it to become, the next step will be fleet-wise sharing. And we are also working with the IHO, International Hydrographic Organization, as well as being a trusted node for NOAA. And we are part of the crowdsourced bathymetry working group with these organizations. So, so we are working in that direction of sharing data. We do share data. We're the first 3D sonar that is a trusted node for NOAA. So we're very excited about that. And we do give a subset of the data now to these crowdsourced bathymetry. So in a way, sharing it among the fleet would almost be like a mini crowdsource sharing link. Can you also locate timber in the water? We have a lot of issues with this destroying our propeller. Well, some of the timber, as if it's in a high sea situation and just floating right under the water, we might not see all of them right when they get in, but as they get waterlogged, they usually go down on an angle, and those are much easier to see as we are looking up toward the sea surface and down. Obviously in a hurricane situation like we have now in the US and the South, you're not going to see, you know, it won't be working well, but we can see a good percentage of the larger timbers. Do you have any Navy clients? Yes, we are currently doing a project under a SBIR with the US Navy, and we have done other ones in the past. We're not on their fleet yet. However, we have systems deployed in the Dutch Navy, New Zealand Navy, actually FMS program to Egypt on several of their vessels, Australian Navy, and we are looking more and more, especially some of the navies use QPS and their Kinsey. So we are working with one Navy in particular now that will be taking our data, not just putting it on their navigation charts, but also using it for their survey applications. So, so yes, we working with navies and would love to meet new ones. How difficult would it be to install retrofit? Can you talk a little about new build versus retrofit? Okay. We do at least 50% of the projects are for retrofit projects. So it's not a challenge. In fact, even in the new builds, sometimes we are installed later in the process. So there's not as much difference. But we work closely with the naval architects and the shipyards on all the projects. We're happy as the manufacturer. We suggest that we review your installation concepts and drawings to make sure that they're appropriately set for the sonar to operate. We have an installation design guide, and we also have all the drawing packages of various types of installations. So this acts as a guide. So we no problem with the retrofits. We have some polar research vessels. How does it work with ice in the water? Okay, we are on many polar research vessels as well as polar cruise ships and private vessels. We're on the Sir David Attenborough. We're on the new Ocean X research vessel. Ice is a very good acoustic target for our sonars, and as you all know, the size of the growlers or the icebergs, they're all much larger underwater that you can't see, with only a small percent protruding. So we have many people who use it specifically because they're going around Greenland, they're doing all sorts of ice travel, and so it's a very good application for that. We've even one of our cruise ships actually went the furthest south in the Antarctic using our sonar successfully, and came back and have been using our sonars for years, and they use the Argos 1000 at this point. You showed a slide regarding fisheries application. How can your FLS be used for fisheries? Well, we don't have a specific product yet for fisheries. However, we have worked in both the US and in the Netherlands with some partners where there was one project with T&O in the Netherlands where they partnered with the fishing fleet and used our sonar to gather data for of all the different schools of fish as they were going up to them, and then they happened to use their own classification algorithms to be able to tell the difference between herring and two different types of mackerel, and so they're using it so that the fishermen could go to whichever of the schools of fish in front of them had the higher percentage of the more likely wanting and the more expensive fish that they want to bring to market. So this has not become a product, and we are also looking for partners globally that we would love to, because we feel the sustainability of the ocean is so important, and lowering the bycatch is, no matter the politics of it, or lowering the bycatch, getting the fish to market faster is a much safer and more important use. So we would love to do more with that. What militaries you work with? Okay, we've that was answered already, but for what applications? Some are for obstacle avoidance completely to protect their vessels. Some are for survey applications. And in the US, we have also done some work with underwater threat detection, like diver detection. It's a whole different software package with some of the same hardware. And so, mainly that has been in the US militaries. And so where we actually, instead of filtering out the small objects or targets, we would look to detect and classify the underwater swimmers, and then also track them as they come toward the vessel. So that could be done actually 360 perimeter around the vessel. Is range dependent on vessel speed? Yes. So because theoretically the Argos 500 could go to the 25 like the Argos 1000. However, you're going to come up on it so fast, and with the delay in interpreting things, we have the spec at 20 conservatively, and 25 conservatively for the 1,000 meter range. The 350 right now, we're recommending up to 18 knots, because again, you might overrun and not have enough reaction time to decide what to do. Obviously, for a machine interface on some type of applications, the response time would be much faster. Okay. I'm working on a proposal for a yacht and have suggested Argos 350. What support can you provide in terms of drawings, installation, commissioning, and the like? Well, if you contact us, even through info@Farsounder, we can right away send you the installation design guide that has all the details, and it references a drawing package. So there's a drawing package for the Argos 350, and that has not only, it has under the transducer, has an underwater mateable connection that is normally on most of our systems on the rear of the transducer module. For the Argos 350, we've also added the option that it could be from a top mounted, just to, in case someone had a faster planing hull and wanted to use it when they go out further away, they can use a hoist and drop it down. So, but we can, installation commissioning, we have our dealers are certified in commissioning in all sorts of countries around the world. And we also have remote troubleshooting. If you have anything, we can even help you understand some scenarios by getting in through remote look, if we can get through onto your network to do that. So we'd love to hear from you. Will a recording of this presentation be available? Well, Clara already answered that. Yep, sales.brazil@m&opartners.global. Can you give some more details on the slide of history mapping in terms of what details can be recalled? Oh, okay. There's, I guess, is that, I don't know if that's answering that. Oh, no, and can we get a copy of the presentation? Yeah, the local history mapping, if time permits, I'll keep going till Clara says no. Yeah, we keep the bottoms, and you can do that separate from the in-water targets, but you can also keep the in-water targets also. But the GPS location, the timestamps, we have all this in the history mapping. But then, you know, as right now, if you're just using the part that's on board, we overwrite it after about an hour. The oldest data you will lose, but we have a wide field of view with all the bottom data within that. I think the edges, I'm not sure if we recall. I think we keep that off because just to have the edge effects, we want to make sure that the data you have is the best. So, but I'm trying to think. I could talk to you offline and give you a presentation all about the local history mapping, and you know, we are in the middle of expanding and making decisions of what type of packages our customers are interested in this. You know, so I'd love to talk to you. Info@farsounder.com can get to me also. And no, there's more. Follow up on the range question. If you're only moving at 5 to 10 knots, can you see beyond the 1,000 meter? With the Argos 1000, we cut off the processing for the product at the 1,000 meters. And if you're going slowly, we also have the option, you can have the wide 120-degree view instead, because the Argos 1000 can have 60-degree view from 500 to 1,000 meters. It can have the 90-degree view from out to the 500 meters. And then you can do 120-degree field of view, which is especially useful if you're looking to go through a difficult place, you're going slowly, looking for anchorage, looking to go through coral reefs or other areas. So, so yes, the sound will continue, past the 1,000 meters, but we cut it off at the 1,000 meters. I think that looks like that is
That's
it.
all. Yeah. So thank you so much, Cheryl. And I would like to thank our audience and see you all.